Alrighty, if you guys want to go ahead and start with your presentation, that would be awesome. And just remember the 10 minutes and my hand signals and the Q&A session and making sure you guys keep things brief, both the judges and the team. Go ahead.
Hi, we're FracPod. My name is Joshi and I'm the CEO of FracPod.
My name is Karthik and I'm the co-COO of FracPod.
My name is Aryan, I'm the co-COO of FracPod.
My name is Mehul and I'm the CFO of FracPod.
My name is Chanchal and I'm the CMO of FracPod.
In the United States alone, there are over 100 million gallons of groundwater contaminated by fracking processes every year. Because of this, disgusting contaminants like acids, slick water, disinfectants, and other chemical additives are flushed from fracking wells seeping into groundwater reservoirs.
Fracking is a process of injecting water and chemicals vertically into a well to break up underground bedrock and to free up oil and gas reserves. During fracking, fluid is pumped down into the well at a pressure so high, it cracks the shale and creates fractures through which the trapped gas and oil can escape. The fracking revolution has enabled the United States to become the world supplier of most of the new oil produced since 2008 and end OPEC's control over oil prices. As a result, fracking has increased energy security and lowered energy prices in the United States, which has made oil companies more inclined to keep existing fracking sites operational and invest in new fracking wells. But
fracking produces massive amounts of inorganic toxic waste. These toxic fluids seep into the groundwater, which can contaminate people's water supply who live near the site. This is where our patent-pending product comes into play to solve this massive problem.
But first, let's talk about the science behind our solution. The two components inside the FracPod are basalt fibers and activated carbon, which are utilized to decontaminate groundwater from inorganic and organic pollutants, respectively. Basalt is a fine-grained igneous rock that has high concentrations of magnesium and iron, which are positively charged elements. These positively charged elements attract the negatively charged heavy metals and dissolve into a harmless byproduct. Activated carbon, composed of black granules of coal or other carbon-rich materials, filter out harmful organic chemicals from contaminated water. As contaminated water flows through activated carbon, the contaminants stick to the surface of the granules and are removed from the water. The coating of the pod is made of polyvinyl alcohol, which is a water-soluble polymer coating that is utilized as an emulsion stabilizer, which can also separate any remaining pollutants from the water. So this is the FracPod, our patent-pending innovative solution to purify groundwater contamination caused by fracking. The FracPod is a small pod coated with polyvinyl alcohol and a polymer resin that is water-soluble. Inside the pod, there is a basalt fiber and activated carbon compound solution that dissolves both organic and inorganic pollutants. Although activated carbon compound technology has been deployed to reduce organic pollutants at fracking sites, the FracPod is unique because it disintegrates both organic and inorganic pollutants with an emulsifier that separates any remaining pollutants. We worked with multiple UGA professors and did in-house testing on the components against hydrochloric acid and slick water to test the viability of our solution, and we determined that these components effectively clean the groundwater. So we created 3 iterations of our pod during the design process to implement the features and benefits we wanted to have in the pod. The first design created was a rectangular shaped pod with an extruded cut at the top to release the solution. However, this iteration was ineffective and it slowed down the speed in which the pod reached the areas of contamination. Our second iteration provided a curved shape that was more ergonomic in water, but its pressure points were equal throughout the pod and would not burst at a high enough water pressure. For our third iteration, we worked with sustainability experts at Georgia Pacific and Kimberly-Clark to help design our pod in a circular shape with a pressure gauge so that it would burst at a high enough water pressure. Also, we sent this iteration for a provisional patent through TIE Atlanta, which makes sure our product cannot be stolen for 12 months in case we make changes after R&D. So here's how the FracPod works. First, the pod is injected vertically into the well along with the fracking liquid. As the pod descends and the water pressure increases, the pressure gauge at the bottom of the pod will burst, releasing the solution and dissolving the polyvinyl alcohol coating, which is also soluble. Finally, the basalt fiber and activated carbon compound solution will attach to the organic and inorganic pollutants to disintegrate them.
This is the most opportunistic time to introduce this solution to the market because newly elected President Biden's clean energy plans include increasing restrictions for fracking site operations, which would then threaten the existing standards of fracking company groundwater contamination. In addition, the fracking market has grown by almost 5,100% in the last decade alone, and is expected to grow even more exponentially. In addition, fracking operations have affected numerous companies. For example, due to excessive contamination of groundwater, the Environmental Protection Agency forced 3 oil production companies to reimburse the city of Poplar, Montana. The fracking companies operating wells were fined over $2 million because of drilling contamination that polluted their city's groundwater reservoirs. Likewise, there are others of hundreds of small large or small fracking wells that have had to pay significant fines to the EPA to continue operating. These are just two reasons why fracking companies need us today.
This is our go-to market strategy in our market size. In phase 1, we are targeting smaller fracking companies because these are customers that are at greater risk of shutting down due to compliance standards by the EPA. Therefore, these smaller energy companies will be more likely to invest in our product initially. Once our product has been operating at smaller fracking wells with success, we will move on to phase 2, where we will target larger oil companies such as Chevron and Exxon because these companies have the greatest pressure to adjust their standards to align with Biden's new clean energy plans. Not only that, but because of increasing energy production globally, fracking is expected to rise, giving our product a bigger target market. For just the US fracking industry, there's a $21.86 billion market size, and in just 10 years, we can expect a $28 to $30 billion market size. After discussing with sustainability experts at Georgia Pacific, we determined that the best way to introduce our product into the market is to demo our solution in local and national oil and gas trade shows. This will showcase our product and its significant benefits to several oil companies and fracking contractors. Not only will this gain publicity about our invention, it will gain customers. We have also created and emailed a list of 150 potential customers, and 30% of the customers in this list have shown significant interest in the FracPod. One of the judges from yesterday's panel, JT Vaughn, is the CEO of IH, a company that focuses on developing and working to commercialize energy technologies, and he offered to connect us with multiple people in the oil industry.
In addition, our product is more effective than our competition. Our main competitors are Desalinatech, Oasis Water, and Osmoflow, a company whose goal is to purify the water that is used in fracking, which is very similar to our product. However, our product has an advantage because we target organic and inorganic pollutants, while other companies struggle to target the organic pollutants. Also, companies like Oasis Water and Osmoflow are unable to save more than 95% of water because they use a basic reverse osmosis method. Overall, our pod targets both types of pollutants and is able to convert more contaminated water to potable water than our competitors.
Initially, we will pitch our product to 15 oil and gas companies who are at risk due to fracking restrictions. We assume that 7 companies will show interest in the FracPod since this is a brand new product that they have never seen in action. From there, each company will get another presentation of the scientific aspect of our product, and we think that 4 companies will want to see our product in action. Each remaining company is shown a demo of how our product works to clean up contaminated water. Due to the demo and credibility we have, we believe that 3 companies will become customers that want to buy our product.
This is how we plan on charging our customers. Our product will be charged at around $10 per pod as our pod clears up around 10 gallons of water. All customers will first have to send information regarding how much water is used so that we can make enough pods for each site. After receiving information about how many pods are needed, we will charge accordingly. Not only that, but our company also charges a one-time $5,000 flat fee. Our solution is cost-effective considering that to purify this extensive amount of water, the government and fracking companies need lots of electricity, and it must go through a rigorous process of energy-intensive boiling and desalination. We plan to sell our pod at $10 per pod deployed. Not only that, but one singular pod only costs $1.54 to make. Due to the low price of creating one pod and what we sell it at, we will make $8.46 per pod. This gives our company an 84.6% profit margin.
In the first 2 years of our company, we don't expect to make any money because we'll be developing and testing to make sure our product is operational. In year 3, we expect to make $3.8 million from the 3 companies that we know will want our product. Due to the success that we know our product will have, we expect to make over 2 times the amount with $7.6 million in sales. In year 5, we expect to have similar increase in revenue with $13.3 million in sales.
These are our milestones for the development of our company. Our first benchmark is raising investor capital. Once we gain revenue, we will develop the prototype for our product by doing extensive research and testing on the basalt fiber and activated carbon compound solution. Work on the final product will commence and a mass production facility for our product will then be operating. Finally, we will pursue and aim to acquire contracts from the 15 companies we will be pitching to.
And here's how we'll spend the $500,000. We will spend $150,000 on R&D, as it is how we know our product will function. We will use $100,000 for mass production because one sushi can purify 10 gallons of water. We will also need to spend money through advertising from oil and gas trade shows, which will use around $50,000. Finally, we need to be able to sustain the company for another 2 years, so the extra $200,000 will be allocated to paying employees and to pay for new channels for mass production and research and development.
In conclusion, we are seeking $500,000 for a 10% equity stake in our company. Overall, our product is eco-friendly and sustainable for the environment. Together, we can help improve millions of people's water quality and improve the condition of our environment. We would like to leave you with a quote from Professor Jack Wong from UGA about the FracPod. Addressing fracking-related environmental problems is a priority. This is what we need for our time in our nation. Thank you.
Alrighty. Thank you guys so much. We are going to go ahead and start off with the Q&A session now. And just again, a reminder to make sure we keep things brief so that everybody can get their questions and responses in within time. This time we can start off with Mr. Kamal.
Hi, thank you for the crisp presentation and very clear manifestation of your idea. I just wanted to ask, where will you? I mean, do you have some ideas? You must be having some ideas on where you would be manufacturing these. You would be outsourcing these the manufacturing bit of the pod, right? And is it possible to do that mass production? How many units will come for 100,000? Roughly about 70,000. I don't know.
So for 100,000 gallons of contaminated water, we would be around 10,000 pods because each pod can clear around 10,000 and 10 gallons per pod. Yes, per pod. And we are going to be first doing R&D testing to make sure our pod functions well and properly together, and then we'll move into the mass production stages.
Okay.
We can go to Mr. Malik now.
So hi, thanks for the presentation. You said the one differentiator you have as compared to the competition is that your solution can deal with inorganic pollutants. What stops the current competitors to add that feature, and how difficult do you think it would be for them?
So basically, in the past presidency, there was more leniency towards the restrictions on fracking companies, but Biden's new clean energy deal is moving towards increasing a lot of restrictions, and a lot of the competitors use their basic reverse osmosis method, which isn't efficient for inorganic pollutants like heavy metals and organic pollutants, so it would be harder for them to move towards that, whereas our pod already integrates those things.
Thank you.
Thank you, Mr. Malik. We can go to Mrs. Alam now.
Great presentation. I just had a quick question about, have you thought about what happens with the waste disposal with the pods after you've actually eliminated all these toxins? And is there a cost factor associated with that?
Right. So actually, they dissolve into a harmless byproduct, and all of the components in the pod itself are 100% water soluble, so there's no additional costs associated with cleanup afterwards.
Mr. Cohen, if you'd like to go next.
Good job, guys. My question is on distribution. So when you have these pods that are pressure, when you actually are going to be shipping large quantities of these, if there's pressure on them, have you gone through basically what the shipping costs and what happens if something does push down on that pressure to release the pods while you ship?
So the pressure actually isn't a massive problem because pressures inside fracking wells are extremely high, and it can only be attained by injecting it with a fluid at extremely high pressures that would be harder to achieve on land unintentionally. So shipping and breaking the pod wouldn't be as easy in distribution channels.
Thank you. We still have some extra time, so Mr. Kamal, if you have another question, you can ask that.
No, my question was the same, like about the exterior. So that's clear. Thank you. No more questions from my side.
Hello.
Yep, you can go ahead.
Yeah. So with fracking, water is just half the issue. Water pollution. A big issue is air pollution. Have you also looked at that? Because that leads to birth defects and a whole lot of other issues in those areas.
So that's another sector that we could potentially go into, but right now, because fracking sites can all be extremely close to people's homes, getting that polluted water could be extremely damaging. So we're focusing on water right now, but that is a possible sector that we could move into.
Right, thanks.
Okay. Thank you guys so much. That should be about it for this round. You guys did a great job.
All right, thank you.
Thank you.